All right, I'm doing a real world problem here, which is going to entail a lot of details. So as you can see, we have a table here right here that shows you the amounts of water that's in a fish tank. And we have the x coordinates are the time values, which are in minutes, and the amount of water is your y values, which is in gallons. So as you can see, I've kind of made a little table change of value on the x-axis. You can see that they are all going up by 1. 1 minute is adding to this time frame. And as each minute goes by, you're losing 3 gallons of water each minute. So that is our slope, that is our unit rate. So when we're writing our equation here, we would be able to do that because we can take a look at the starting value, which is when 0 time has passed, which is a starting value of 20. So that is my y-intercept. And then as you can see, we're losing 3 gallons for every 1 minute, which is our slope. So our equation for this problem would be y equals negative 3x plus 20. So now we're going to look at what happens with the real world meaning in this. So our x values, as you can see, again, were the time values in minutes, and our amount of water in gallons is the y value. So I just got that information from right here in this table. And I just put a little quick description as to what is happening. So the tank is losing 3 gallons per minute in this tank over the time. It says to write a short description or explanation of the data table. And what happens is the number of gallons is increasing or decreasing. And then how do I know how they connect to our equation? So my explanation here would be just simply that every 1 minute of time that goes by, 3 gallons are coming out of that tank. And it's decreasing, and it starts at 20 gallons, which was the starting value, which is my y-intercept, and it decreases at 3 gallons each minute. Now notice I don't put a negative in there because I said the word decreases. So when I put decreases, that means that it is the negative value. Now the last thing I am doing right here is going to be the table, so I didn't graph this. So you can see that the x-coordinate was time, so I put the x-axis time in minutes. Y coordinates or the gallons, so my amount of water in gallons is over here, and I just used the graph. So I just skipped every other line and then put the 1, 2, 3, 4, 5, and then I'm going to graph my values. I did these by 2s, so I just labeled 10 and then I labeled 20. So 0 and 20 would be right here, and then when we're looking at graphing these again, these are going by 2s, so 1 and 17. So this is 18 right here, so that means that 17 would be right here. Oops, and I would have to put this right here, not there. And then I'm going to go to the next number, which is 2 and 14. So I'm going to put 2 minutes. I want to go to 14, so this is 10 right here, so this would be 14. I'm going to fix that extra dot in just a second. And then we've got 3 and 11. So if this is 10, this would be 11 right here. And then the last point is 4 and 8. So this is 8 right here, and then I'm going to go over to 4, put a dot right here, and then I can continue going on. But you can see that that is a straight line other than the little mistake that I made right there, which I'm going to fix in 1 second. But that is how you would go ahead and do a real world problem like this, where you are using the table values as well as graphing it, explaining it, and writing the equation and the whole information. And again, you would want to make sure that you connect all points once you've got them, and just connect those dots like that. We would not put an arrow right here because it's not going to go any higher. Obviously, the tank is full at 20, and it would continue to go down until you got down to the bottom here. So we can continue to put an arrow right here, and that would be your finalized information. If you'd like more questions like this, you can find them in my YouTube channel, You Want Algebra. Check these out under a new category called Real World Context.